SpaceX's Starship program has won $53 million from NASA to perform a full-scale test of orbital propellant transfer, taking the company and space agency's relationship on the crucial technology to the next level. NASA revealed the results of its fifth round of tipping point solicitations on October 14, announcing awards of more than $370 million total to 14 separate companies. The main intention of these awards is to mainly focus on the development of commercial space technologies to progress with their future missions. As part of these awards, SpaceX's Starship launch vehicle also won an award to demonstrate full-scale test of orbital propellant transfer, a key in-flight refueling technology that is at the heart of the operations. Refueling in orbit is a vital step for SpaceX to enable its Starship spacecraft to make the journey to faraway places, including the Moon and Mars. The main objective is to launch multiple Starships, some destined to top up others while in orbit. SpaceX wrote the news in a tweet. Combining Starship's rapid reusability with orbital refilling is critical to economically transporting large numbers of crew and cargo to the Moon and Mars. More than $370 million was awarded to 14 separate companies in total. NASA invested on mainly three categories: cryogenic fluid management, lunar surface operations, and closed-loop, i.e. autonomous, descent and landing capability demonstrations. This is the second time NASA has awarded SpaceX funding for propellant transfer development as part of tipping point contract. Last year, on October 2019, SpaceX was awarded $3 million to develop and test cryogenic fluid coupler prototypes for large-scale in-space propellant transfer. It was NASA's first direct investment in Starship. Now it seems, NASA was completely satisfied with the results of that icebreaker test. That's why they have decided again to fund a full demonstration of Starship propellant transfer for $53.2 million. NASA's award description reads as follows. Large-scale flight demonstration to transfer 10 metric tons of cryogenic propellant, specifically liquid oxygen, between tanks on a Starship vehicle. SpaceX will collaborate with Glenn and Marshall. According Ars Technica's Eric Bergen notes, NASA investing 8 figures in a SpaceX Starship propellant transfer demonstration, let alone some $250 million overall in 4 separate companies, comes as a major surprise. Thus, NASA is effectively testing the tolerance of political stakeholders in programs like Orion and SLS, programs that exist more to preserve jobs and prop up congressional stakeholders. If a magnitudes cheaper and more capable solution like distributed launch and orbital refueling were demonstrated under NASA's own purview, it might become a lot harder to defend heritage programs that have been hemorrhaging 20% of the space agency's annual budget for almost a decade. As per NASA, this round of tipping point contracts may remain valid up to 5 years. Aside from SpaceX, the United Launch Alliance, ULA, won an $86.2 million contract for testing precise tank pressure control, tank-to-tank transfer, and multi-week propellant storage with a Vulcan Centaur upper stage. Lockheed Martin won an $89.7 million contract for an in-space demonstration mission using liquid hydrogen for testing fuel management technique, to test more than a dozen cryogenic fluid management technologies. SpaceX bagged $53.2 million for a large-scale flight demonstration to transfer 10 metric tons of liquid oxygen between tanks on a Starship vehicle. It clearly indicates that NASA has planned to fund a single-ship orbital flight test in which a Starship prototype, which will most likely attempt to transfer liquid oxygen between its main LOX tank and a smaller header tank. The Starship is currently under development in SpaceX facilities in Boca Chica, Texas. Will replace the company's existing launch vehicles. At this moment, SpaceX mainly relies on the Falcon 9 Block 5 for delivering payloads to the International Space Station, ISS, and low Earth orbit, LEO, amongst other destinations. These rockets use the company's Merlin 1D engines with roughly 845 kilonewtons of thrust and a gas generator power cycle. The Starship will be taking over the Falcon 9, which uses a completely different propulsion system. Starship's system will utilize SpaceX's brand new Raptor rocket engines. As per expectations, it may output roughly 2,200 kilonewtons of thrust and a stage combustion power cycle that is more efficient than the Merlin's. Mr. Jim Bridenstine, the NASA administrator, emphasized on the need of developing fuel management techniques when responding to a question after his keynote at the Lunar Surface Consortium. Jim mentioned, "Well, I will tell you, I think it will be both. I think to the extent that it will be government users, it will be the government as a customer of a commercial provider, as far as those fuel depots go. As far as when they materialize, I don't want to put a date on that, but I will also say that when we look at how we are spending the tipping point resources, $270 million of the $380 million is focused on the storage of cryogenics in space. And of course, when we think about companies like SpaceX and the Starship, their architecture is heavily reliant on the ability to transfer cryogenics on low Earth orbit for the purpose of taking a system all the way to the Moon. Their system in fact doesn't appear to require a fuel depot around the Moon. Their system would require a fuel depot in orbit around the Earth. SpaceX has also been selected by NASA to develop a Starship variant to send crews to the surface of the Moon as soon as 2024. NASA's relentless support to SpaceX could end up isolating other stakeholders in the agency's other launch plans, including the Orion capsule and the Space Launch System, as Ars Technica's Eric Berger points out, giving the agency far more affordable options to carry cargo and passengers to faraway destinations. Let's take a look at the awards grabbed by the other companies. Intuitive Machines was awarded $41.6 million contract to develop a Moonhopper spacecraft, which is capable of hopping around the lunar surface propulsively. Nokia of America Corporation of Sunnyvale, California, won $14.1 million. Based on terrestrial technology, they wish to deploy the first LTE/4G communications system in space. It is capable of supporting lunar surface communications at greater distances, increased speeds, and provide more reliability than current standards. Maston Space Systems of Mojave, California, was awarded $2.8 million to manufacture and demonstrate a universal chemical heat and electrical power source attachment. It allows payloads to survive in the extreme environments which can be experienced during the lunar night and in craters. Alpha Space Test and Research Alliance of Houston was awarded $22.1 million. They are going to conduct small experiments access to the lunar environment, which is mainly intended to collect data and experience exposure to the ultraviolet and charged particle radiation. Sierra Nevada Corporation of Madison, Wisconsin, bagged $2.4 million to develop demonstration-scale hardware. It runs on methane and concentrated solar energy to extract oxygen from lunar regolith. The hardware can be tried on a commercial lunar lander for a full-scale production plant's feasibility using this process. Teledyne Energy Systems of Hunt Valley, Maryland, was awarded $2.8 million. They will be focused on building a hydrogen electrical power system to enable a fuel cell with an operating lifetime of 10,000 hours. Eta Space was awarded $27 million for a small-scale flight demonstration of a complete cryogenic oxygen fluid management system. It is going to be integrated with Rocket Lab's Photon spacecraft bus and launched on an Electron rocket. PH Matter of Columbus, Ohio, won $3.4 million to manufacture and demonstrate a reversible, regenerative fuel cell capable of producing power and storing energy on the lunar surface. The small business will collaborate with Glenn as well. Astrobotic Technology of Pittsburgh bagged $5.8 million. They demonstrated a fast, wireless charging system that is capable of resolving issues related to some technologies on the Moon. They're going to manufacture and deliver flight units for potential use on commercial robotic landers. They will collaborate with Glenn. Precision Combustion Incorporated of North Haven, Connecticut, won $2.4 million for building a cost-effective power solution for space, military, and everyday applications on Earth. As per the company, The solid oxide fuel cell stack will generate power directly from methane and oxygen propellants and other in-situ resources. SSL Robotics of Pasadena, California, won $8.7 million to manufacture a lighter and less expensive robotic arm for lunar surface applications, in-orbit servicing, and terrestrial defense applications.